Welcome to Daring Marina YouTube channel. Today we will be discussing about single stage air compressor, their basic theory with a PV diagram. We will be discussing about this topic. Okay, single stage air compressor. So basic theory of an air compressor is when the piston moves from BDC to TDC, air will get compressed. As a result, pressure increases and therefore volume decreases. Here means piston move from BDC, from the bottom dead center to top dead center, then air will get compressed in inside a piston. So the pressure will increases, therefore volume decreases. Work done to compress the air is converted to heat energy in the air, so that air temperature will be increased. This is the basic theory of air compressor. Means when the piston is moved from BDC to TDC, air will get compressed. As a result, the pressure increases and volume decreases. Therefore, work done to compress the air is converted to heat energy in the air, so that air temperature is increased. During compression, if all the heat generated is taken by cylinder wall, then it is called isothermal combustion. Okay, during compression, if all the heat generated is taken by the cylinder wall, then it is known as isothermal combustion. Here, further temperature rise is avoided and the compression is taking place at constant temperature. Here we know that further temperature will be avoided and compression is taking place at constant temperature. The relation between pressure and volume can be found by Boyle's law, that means PV is equal to a constant. Relation between pressure and volume could be found by Boyle's law, that is PV is equal to constant. We know that during compression, if all the heat generation is taken by cylinder wall, then it is called isothermal combustion. Here, for the temperature here is avoided and the compression is taking place at constant temperature. The relationship between pressure and volume would be followed by Boyle's law, that means PV is equal to a constant. If there is no heat transfer from the compressed air, then all work done during combustion would be appear and stored as a heat energy. This is known as adiabatic combustion. That means if there is no heat transfer from the compressed air, then all work done by combustion would appear to be in a stored energy. This is known as adiabatic expression. The relation between pressure and volume would be found out by PV gamma equal to a constant. Gamma is equal to 1.4 for air. Okay. So if there is no heat transfer for compressed air, then all the work done during combustion would appear to be as stored heat energy. This is known as adiabatic combustion. This relation between pressure and volume would be by PV gamma equal to constant, that is gamma equal to 1.4 for air. Actual combustion process in an air compressor is between the isothermal and adiabatic, and it is referred to as polytropic combustion. So here we mentioned about two scenarios, that means adiabatic combustion, isothermal combustion and all. But actual combustion process in air compressor is between isothermal and adiabatic, and it is referred to as polytropic combustion. The relation between the pressure and volume, that means PV raised to n, PVN equal to a constant, that n is a value about 1.25 to 1.35. Its value between 1.25 to 1.35. Okay, actual combustion process in an air compressor is between isothermal and adiabatic, and it is referred to as polytropic combustion. The relation between pressure and volume, that means PVN equal to a constant, where n is the value of about 1.25 to 1.35. Okay. PV diagram with explanation. Here we can say that isothermal, polytropic and adiabatic. Three types are there. PV diagram with explanation means isothermal, polytropic and adiabatic. PV diagram with explanation. It is a PV diagram of a compression. Here we can say D to A, that means during intake stroke. Assume that there is no bumping clearance. Bumping clearance is 0. Then initial volume when the piston at the top is 0. Okay, when the piston is at top, then initial volume will be 0. Thus, as the piston moves from top to bottom, will move from TDC to BDC, volume of air V2 is drawn in the compressor from the atmosphere with pressure V1. Then the temperature of air will be T1. Okay, here D to A means here we are considering there is no bumping clearance, so bumping clearance will be 0. So initial volume at the piston at top will be 0. Then piston moves from TDC top to bottom, that is TDC to BDC. Then volume of air will be V2 is drawn by the compressor from atmosphere with pressure P1 and temperature of air equal to T1. Okay. A to B will here they consider compression. As the piston moves up, the air is compressed polytropically. That means it is a combination of both isothermal and adiabatic. So polytropic, that PV raised to n equal to constant. So here the pressure of air increases from P1 to P2, volume decreases from V2 to V1, and temperature increases from T1 to T2. Here is what happened. A to B during compression stroke means as the piston moves up, that means from BDC to TDC, the air is compressed polytropically, that means PV raised to n equal to a constant. The pressure of air increases from P1 to P2 and volume decreases from V2 to V1 and temperature increases from T1 to T2. This is what happening. Then B to C, there will be delivery stroke. That means compressed air at the pressure P2 and volume V2 and temperature T2 is delivered out of the compressor to the air receiver. Here what happens from the air compressor? The compressed air at the pressure P2 and volume V2 and temperature T2 is delivered to the compressor to the air receiver. This is what happening. Thank you.